All right, hello and welcome everybody. In this little video, I'm going to be taking you through this year's Exam 1 VCAA paper. These are my personal solutions for this exam paper, so it's quite possible that I'm going to make some mistakes while going through this. So just letting you know that any edits that I need to make are just going to be in the description of this video. So yeah, going through this, we'll go through question by question. I'll give you my thoughts on each of the problems. So question one, we've got what we would usually expect for question one, which is some kind of chain rule question. So to answer this question, we apply the chain rule. So if this is equal to, hang on, let me get the right thing up. So that's equal to, there we go, draw. So this is equal to uv. This function is uv, then this will be derivative of u times v plus the u times the derivative of v. So if we have, if we take u as x squared, the derivative of that is going to be 2x. We're going to multiply that by cos x, and then for u, this is going to be x squared. We'll multiply that by the derivative of cos, which is a negative sine x. So this is going to come out as 2x cos x minus x squared sine x, right? Yep, awesome. So moving on to the next question, we have to find the gradient to the tangent at this point here of this given function. So when we're talking about gradient to a tangent, what we need to do here is we need to take the derivative to find the equation of the gradient and then sub in the point. So again, pretty typical here for an exam one sort of question. So first thing that we might do here is write this in terms of indices. So I would say this is the same as x plus 1 to the power of a half over here. And then if I take the derivative of that, what we need to do is count that power down by 1 and then multiply by the power. So we're going to multiply the half out the front. So half times 6. And then we have x plus 1 to the power of negative a half, and then the derivative of 5 is just 0. So this is going to come out as 3 up the top, and we have the square root of x plus 1 down the bottom. That's our derivative function. And then to find the gradient at this point, we just sub in x equals 8. That gives us 3 over the square root of 8 plus 1, which is just equal to 9. So that's 3 over 3, which is just equal to 1. That's our answer for that second question. All right, now let's suppose we have a function defined for x greater than negative 3 over 2, and this is our derivative. So we've been given the derivative function. We need to work out the original function, so we're going to apply the antiderivative to do this one. So once again, we can write this in terms of indices. So this is 2x plus 3 to the power of negative 1. Then we need to work out the derivative of, the integral of this. So we can see that gx is going to be equal to, and there'll be a plus c, don't forget. So it's going to be that multiplied by 1. We're going to, sorry, this is logarithm. Yep. So yeah, the integral of this is going to be a logarithm. It is going to specifically be a half times ln of 2x plus 3. We can get this by looking at our formula sheet. Okay, and then there's going to be a plus c at the front here. So therefore, if we use our initial condition here, it's g1 is equal to a half ln of 2 plus 3, which is 5, plus c is equal to 0 according to what we have here. So therefore, that implies that our c value is going to equal negative a half ln 5, and therefore we can confirm that g of x is going to equal a half ln of 2x plus 3 minus a half ln of 5. And we could just leave the answer like that, I believe. All right, so moving on to the next question. We have here a trigonometric function. We're trying to find the range of that function. So we can see here that the amplitude is 2, the period is 2 pi over 2, so that's pi. And we can see that its equilibrium point is 1. So we have 1 plus or minus 2 is going to give us our range. So the range is going to be from negative 1 to 3 for this particular function. Now we need to solve it over this, so solve it over its given domain, which is from 0 to 2 pi. So to do that, we're going to just set up the function is equal to 0. So that's 2 cos 2x plus 1 equals 0. We can transpose that to get cos 2x is equal to negative a half, and then we can have a look at that and try and work out what we can find from this particular thing here. So that's going to give us, okay, so for a cosine function equal to a half, that means we're dealing with some multiple of 60 degrees or pi on 3. So 2x is equal to something involving pi on 3, just based on our, our triangles. We have, if this here is, let me draw that a bit better. So one of our triangles was the pi on 6, pi on 3 triangle, where this here is 1, so that's 1 root 3, 2. So yeah, if we look at this, adjacent over hypotenuse, that's a half. And of course, we're also looking at trigonometry here. So where's cosine negative? Well, if we look at the x-coordinates of a point on the unit circle, it's negative in the second and third quadrants. So we need to consider the solutions in those two locations there. Let's get rid of that. All right, so let's continue with this. So that's going to be, okay, so it's going to be some multiple of an odd number of pi's plus or minus pi on 3. So for example, we're going to have pi plus or minus pi on 3. And given that we have a period of pi, we're going to actually end up with 4 solutions. So given that the period's been halved, we're going to have to multiply this by 2. So our solutions are going to be, for example, if we go pi plus pi on 3, that's going to be, or pi minus pi on 3 rather, to start off with, we have 2 pi over 3. We're going to have 4 pi over 3. Then if we do another rotation, it's going to be like 3 pi plus or minus that. So it's going to be 8 pi over 3, and then 10 pi over 3. That gives us 2x. And then, therefore, if we divide both sides by x here, we're going to get that x is equal to each of those divided by 2. And they're all even numbers in the numerators there. So we're going to get pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. And once again, there are 4 solutions here because that's how many are going to fit into 2 pi. So if we exceed 5 pi over 3, we'll be larger than 2 pi. We're less than 2 pi on 3, we're less than that. So there's only these 4 solutions for this particular question. Just put a little box around that because otherwise it's a bit messy. Okay, so now we need to switch this. So first up, what we can do is we can put in our key endpoints. So what did I say before? Firstly, I said that the period was equal to pi. And we have these key values. Sorry, what's going on? Updates are installed. Okay, that's not going to restart my computer, is it? Okay, cool. So let us do this. So we need to put in, so from pi on 2 to 3 pi on 2, what we can check is what is the value of the function when we have pi on 2. So at pi on 2, we have 2 cos pi on 2 times 2, so that's just times pi plus 1. And 2 times, so cos of pi is equal to negative 1. So this is negative 2 plus 1, so that's equal to negative 1. So our first endpoint here is going to be pi on 2, negative 1. Our other endpoint at 3 pi on 2, that is 1 period away from this previous one, so we can fill that in as the same value. Okay, so that's that point there, pi on 2 plus pi gives us 3 pi on 2. And then we have half that period is going to be where the maximum is going to occur, so that there is at the point pi 3 pi on, sorry, pi 3. And then we can sort of fill in our general shape here. So it's going to go down to our equilibrium line 1, and then that's where it's going to sort of change concavity. And it's going to look something like that. So it's going to go down to that point where it changes concavity, and then it's going to look like that. And of course, it's good practice to also label the, it does say only label the endpoints, but I just are on the side of caution here. We've got a maximum here as well. I should also put in these turning points, the x-intercepts. So the first one here, based on our previous answer, that's going to be a value of 2 pi on 3, 0, because of course, if you think about this, that first one would have occurred here, so that's pi on 3. Next one's going to be 2 pi on 3, and then the next one over here should be 4 pi on 3, 0. I think that should be right for that question. Okay, moving on to the next question here, we have this little one here. We have a probability distribution function. with regards to probability, density functions, whatever, the sum of all of the probabilities needs to equal to 1 here. So if we add up all of these little fractions here, we should get 1. So let us do that and see if we can simplify it down. So first up, I'm just going to pay attention to the ones that have the same denominator. So we have 2k plus k over 75, so that's 3k over 75 plus 4 over k plus 2 over k, so that's 6 over k is equal to 1. Okay, now I can first simplify down that first one there. So 3k over 75, that simplifies down to k over 25 plus 6 over k is equal to 1. Next up, we can try and work out how we can solve this. So what I might do here is make them both have the same denominator as one another. So I could do, like I could say that that's going to be equal to k squared over 25k plus 6 times 25, which is 150 over 25. Okay, so my idea here is I want to make both fractions have the same denominator just to make it easier for myself. And then because they both have 25k as their denominator, I can just multiply both sides by 25k. And then I could make one side equal 0. So what I'm going to end up with is the quadratic k squared minus 25k plus 150 is equal to 0. And once again, that's nice because we've just got a quadratic here. We can just factorize that. So if we think about two numbers that add to give negative 25, multiply to give 150, we don't have to think about it too much because we have been given the answer right here. But it is in fact going to be, so 10 times 15, or negative 10 times negative 15 would equal 150. And negative 10 plus negative 15 would equal negative 25. So it is going to factorize like this. And therefore we can see that k is equal to 10 and 15 by the null factor law. Okay, moving on to the next question here. So we're now assuming that k is equal to 15. So what I would do here is just go ahead and just sub that in before we do anything further. So that's 4 over 15. Then this is 2 times 15 over 75. So that's the same as 2 times 15 over 75. So 30 over 75. 75 is divisible by 15, right? Yeah, so that's, sorry. Right, or is it not? So that's so 30 over 75, that equals so 6 over 15. Yep, so 6 over 15 should simplify down to, so that's 6 over 15 there. Sorry about that, I'm just needing to check to make sure that was right. Oh yeah, 6 over 15, and then we can simplify that further down to 3 over, so 2 over 3. Yes, 2 over 5. Sorry, guys. 2 over 5. Okay. And then this one here is going to be 1 over 5. Yep. So it's 15 over 75. 15 goes into 75 5 times. Okay. And then we have here at the end here 2 over 30. Sorry, 2 over 15. And that's our fractions. Okay. Substituted them in there. Now, we need to find probability that x is larger than 1. So the probability that x is strictly larger than 1. So that's the same as saying, what is the probability that x is equal to 2 plus the probability that x is equal to 3? Okay, so if x is larger than 1, it could be 2 or 3. So that's just 1/5 plus 2/15. Once again, we can write these two fractions with the same denominator. So that's going to be equal to 3 over 15 plus 2 over 15. So that's equal to 5 over 15, which is equal to 1/3. Cool. And now trying to find EX here, once again, we're still assuming that K is equal to 15. What we can just do is we can just basically multiply each of those X's by their associated probabilities. So this one is going to be 0 plus 1 times 2 over 5. So 1 times 2 over 5 plus 2 times 1 over 5 plus 3 times 2 over 15. Okay, and now let's simplify that down. So that gives us 2 over 5 plus 10 over 5 plus 6 over 15, which, if we write each of those as a multiple of 15, so that's 12 over 5 times 3, so 36 over 15 plus 6 over 15. So that is equal to 42 out of 15. Right, yeah. So 42 over 15, and then we can see that both of them are divisible by 2, so by 3. So therefore, if we go this one divided by 3, that is going to be 14 over 5. That's not what I got before. Where did I go wrong here? So 3 times 2, so it's 6. How did this happen? That's 5 over 5. Sorry, no, it's 2 over 5. Okay. All right, let's cancel all that. Go back. Always the arithmetic that gets me. Over 15. Okay, so that is going to give us 4 over 5, which is the same as 12 over 15. 12 over 15 plus 6 over 15, which is equal to 18 over 15, which is divisible by 3. So that is 6 over 5. Yeah, awesome. Okay, 6 over 5 is the answer there. Fantastic. Whew. All right, moving on. So this one here, we've got pretty classic question. They come up quite a lot. We've got some sort of exponentially thing written in terms of a quadratic. So we could sub in a. I'm just going to use the ex because we've seen dozens of these before. So another way of writing this is like ex squared minus 8 times ex plus 7 is equal to 0. So it's a quadratic in terms of e to the x. So therefore, we're looking for two numbers that add to give -8, multiply it to give 7. So those two numbers are -1 and -7. So this simplifies down to e to the x minus 7 and e to the x minus 1 is equal to 0. And therefore, we need to solve when each of these things are equal to 0. So if we consider the case when e to the x is equal to e to the x minus 7 is equal to 0, rather, that tells us that e to the x is equal to 7, which tells us that x is equal to the natural logarithm of 7. So that's our first answer. And then if we consider the second case, we have e to the x minus 1 is equal to 0, which gives us that e to the x is equal to 1, which gives us that x is equal to 0, because of course e to the power of 0 is 1. So those are our two solutions, natural log of 7 and 0. Okay, so now we need to consider the function has exactly one stationary point, which is a local minimum. So we're dealing with something to do with the derivative. So let's just go ahead and take the derivative of this function. Minus 8 e to the x. So that there is the derivative of this function, just using our knowledge of exponentials. So the derivative of e to the x is just e to the x. So this gives us this. We're after the fact that this has a local minimum. So we want to know when is this equal to 0, basically, because we want to figure out something about that minimum. So that's equal to 0 when e to the 2x minus 4 e to the x is equal to 0. I'm just dividing both sides by 2 there, so I've just gone 0 divided by 2 to cancel that one out. Then we can take out the x, so e to the x there. We can write this as e squared minus 4 is equal to 0. Okay, so we end up with this. So I've just factorized that in terms of e to the x. All right. Does that make sense? E to the x. No, that's not right. E to the x minus thing. Well, e squared is not equal to 4. So how did I do this before? So that's 2 e to the x minus 5. Right. So we need to know our log law, sorry, our exponential laws for this one. So yeah, when is that equal to 0? It's equal to 0 when, expand that. Okay. Because then we just get, um, oh, it's another quadratic. Yeah, sorry. Okay, so yeah, going back to here, this is, so we could write this as, e to the x squared minus 4 e to the x, yeah? So therefore, if we take out the e to the x, we're left with an e to the x here, minus 4. Okay, so yeah, so it's another quadratic equation. So if we were to consider each of these two cases, e to the x, so null factor law on this factorized expression, e to the x does not equal 0. It's not possible, so we just have to look at this side of the equation here. So we have e to the x minus 4 equals 0, implies that e to the x is equal to 4, which implies that x is equal to ln of 4, which we could also write as ln of 2 squared, which is equal to 2 ln of 2. So that's applying our index laws and our logarithm laws to solve that one. All right, they love the quadratics in this little test here, I think. Okay, so binomial of 6. So the way that this is written here is we have like a random binomial variable where 6 is the number of trials and 1 over 4 is the probability of success for whatever this particular thing is that we're doing an experiment of. So we need to then consult our formula sheet, and I will do that here. So if we look at a formula sheet, we can see the formulas for the binomial random variables when we look at variance, which is the same as sigma squared is equal to np1 minus p. Okay, and then we basically just need to substitute our values into that formula. So here n is equal to 6, p is equal to a quarter, 1 minus p is equal to 3/4, and then we can just see, okay, so first up, we'll cancel this out. This is going to be 3 over 2, so that's 6 over 2, which simplifies down to, no, sorry, that's not as simple as that. Okay, because we have, yeah, so 4 times 4 down the bottom. So that is, all right, let's just do it the long way. I don't want to cut any corners here. So 6 times 3 is 18 over 16. And then we can divide both of them by 2. We get 9 over 8 as our answer. Okay. All right, cool. All right, next question. So we have the probability that x is greater than or equal to 5. So if we have x is greater than or equal to 5, that tells us that x is either equal to 5 or x is equal to 6. So we need to work out the probability that x is equal to 5 plus the probability that x is equal to 6. And remember, there's a total of 6 trials, so we don't need to do any higher than that. So the probability that x is equal to 5 by the binomial theorem, that means that we've had so if x is equal to 5, we've had 5 successes, so that's 1 over 4 to the power of 5. We've had 1 fail, so that's 3 over 4. And we need to multiply that by 6 because there are 6 options for the one that could fail. So that 6 is coming from, 6 choose 1, 6 choose 5. Then we're going to add just 1. So 6 choose 6 is 1 times 1 over 4 to the 6 times 3 over 4 to the 0, which we don't have to write out. All right, so working this one out, this is going to give us, first up, it's in terms of 2 to the b. I know I was a bit worried, do we have to work out 4 to the power of 6? But no, we don't have to do that here. So that's 3 times 6 up the top, which is equal to 18 over, now this is 4 to the power of 6. So yeah, let's write that out. So 4 to the power of 6. Another way of writing 4 to the power of 6 is 2 to the 2 to the power of 6, which we could also write as 2 to the 12. And we're going to add to that this one here, so 1 over 4 to the power of 6, which is just 1 over, same thing, 2 to the power of 12. So all things considered, that's just equal to 19 over 12 to the power of 12. Moving on, we want to verify that x is equal to 0 is a solution of this particular function. So the way that we verify a solution is we basically plug it into the function and we hope that we get 0 at the end. And here we're told to verify it, so it makes our life a little bit easier, I think. So that there is 125 minus 25 minus 16 times 5. Which is something, minus 20, so we can probably work out what that something is. If we see that's 125 minus 25, that's 100 minus 20, so this must be 80, right? Yeah, so yes, that does make sense. Yes, that does make sense. Okay, so we've got that, so therefore that's equal to 0. Yeah, awesome. Again, I'm kind of cheating on the multiplication by 16 just by seeing that it must be 80, but yeah, that works out. All right, so moving on to this question here, we have fx in the form of x plus d squared times x minus 5. Okay, so this is quite nice for us here because we have verified one of those solutions. So if we want to factorize this fully, we can just use synthetic division. So we've got our solution, so I just stick that out the front here. We put in the coefficients 1, -1, -16, -20, and we just do our little procedure. So we do 1 times 5, first up we drop down the 1. 1 times 5 gives us, positive 5. -1 plus 5 gives us 4. 5 times 4 gives us 20. -16 plus 20 gives us 4. 5 times 4 is 20. Answer is 0. We're good. Okay, so that tells us that this function factorizes. So let's just say, therefore, f of x is equal to x minus 5 times x squared plus 4x plus... Can you not, please? Okay. 4. Okay, cool. And then, of course, that second thing there is a perfect square, or you can think two numbers add to give 4, multiply to give 4. It's 2 and 2. So this is x minus 4, x plus 2 squared. So therefore, d in this little expression here must have been 2. All right, moving on to the next question. Okay, so now that we have our function, this should be pretty straightforward. So it's been given to you that our two zeros are, well, let's just write out the equation again. So this is f x is equal to x minus 5, x plus 2 squared. Okay, so we have our linear factor of 5, so that's over here, and we have our touch and turn factor of -2, so that goes here. And if we want to work out what this y-intercept is, we just look at the expanded form, and we can think, okay, if x equals 0, y is equal to -20, so we can just go ahead and put that in here as our minimum. And definitely not drawn to scale, this little graph here, but that's fine. At least the x and y axis. Anyway, so now we have a new function which is equal to f times g. So this f, how would I write it? Just fx gx is going to be equal to x plus 2, x minus 5, and then times by that, so it's going to be x plus 2 cubed, x minus 5. Now, if we have a think about this, we're after a stationary point of inflection. We don't have to do any derivatives here. The stationary point of inflection is going to occur at this this cubic power here, x plus 2, which means that x is equal to -2 is going to be the stationary point of inflection. And when x is equal to -2, we can see y is equal to 0. So therefore, the coordinates are going to be -2, 0. So we can kind of get that by looking at the function. But if that's not satisfactory for you, we just need to remember that if we have a factor that is cubed, then that is going to be a stationary point of inflection. So that's the answer here. Now, the values for x for which fx times gx is greater than or equal to 0. So we have here now fx gx is a quartic, right? So what do we know about quartics? It's going to look something like this. It's going to go down. It's going to reach. In fact, why don't we just kind of sketch it over the top here with green? It's going to kind of look something like this. It's going to go down like this. Then it has this stationary point of inflection. So it'll go down like that. We'll do like this thing here, and then it'll go down and it'll come up at its factor over there. It's not going to look exactly like that, but we can see that the two endpoints are going to be positive gradient, negative gradient on either side, just like a parabola. So kind of looking at that little sketch there, we can kind of answer this question. So when is this function above the x-axis? When is it greater than or equal to 0? So we can say, therefore, f(x)(gx) is greater than or equal to 0 when x is an element of, and we need to write this in the correct notation, so from negative infinity up to, what was that point, -2, and also, so union with 5 up to infinity. And you could write that using interval set notation if you prefer, but interval notation I think is easier for this particular one. All right, moving on to the next one. So now we have a continuous random variable with this as its probability density function. We want to find k such that probability that x is greater than k is equal to 9/6. So we need to write this out as an integral to start. So we have integral from, so this is x is larger than k, so k is our minimum value up to 4 on 3 of this thing here. I'm just going to take out the 3/8 right from the get-go, because otherwise it's going to get messy. Of 4 minus 3x dx must be equal to 9/16. All right, so now we need to evaluate that integral. So again, we'll leave that 8/3 at the front here. We're going to step up the power here, so that's 4x minus 3/2x squared from from k up to 4/3. Got to be careful with these integrals. Let me just check to see if I'm on the right track. Yes, I think that's good. All right, let's see. So yeah, got that. Now we'll go ahead and sub in those endpoints. So 8/3 times our larger endpoint, which is 4/3. So this is 4 times 4/3. Yeah. Sorry, the 8s and 3s got reversed. Yeah, okay, that's don't even know how I did that. So we've got 3/8 up to 4x minus 3/2 x squared. Okay, there we go. Going back to that, that's equal to 3/8 times 4 times this. So that is 4 times 4/3 minus 3/2 times 4/3 squared. And we need to subtract from that the thing with k, not 0. So this is going to be 4k minus 3/2 k squared. Okay, so let's see what we can simplify down here first. Okay, so we have here yeah, so we can split this if we wanted to, but yeah, just to save time, we can see that this is going to be, the 3's there are going to cancel out. There's going to be 16/8, so that's going to be 2 there at the front. Then we're going to have, so these 3's here will cancel out, and then there's another 3 at the front there. So that is going to cancel out with this here, because we have 3 squared over 3 squared, so that's cancelled. And then we have a 16/2 times 8, which is also cancelling out. So that's just 2 minus 1 for this first one. Then we have 3/8 times 4k. So that's going to give us 3k over 2. Yep. Minus 3/2 times that. So that's going to be equal to 9/16k squared. Good? I think we're good. Cool. Okay, and that thing is equal to 9/16. Okay, cool. All right, so we'll expand this and then we'll write it as a quadratic, because this appears to be yet another quadratic. So this is going to be 9/16 So we have a quadratic equation. I'm going to subtract that from both sides. We get 9 over 16 k squared minus 3k over 2 minus 9 over 16 is equal to 0. And then we need to factorize this. First thing we might want to do is get rid of those 16s. So I'm just going to multiply both sides by 16 here to give us 9k squared. Now we need to do 16 divided by 2 is 8, and then 8 times 3 is 24, minus 9 is equal to 0. There's a mistake there somewhere. 9k. Where did we go wrong here? Oh, yes, of course, because we also have the 2 minus 1 over here. Now that's equal to 1, right? Subtract that, 9 over 16 minus 1 is going to be actually 7 over 16. So this here would be plus 7 over 16. This gives us plus 7 here. Okay, there we go. So that was this term over the front here we need to keep track of. All right, so now we need to factorize 9k squared minus 24k plus 7. Fair bit for a 3-mark question, I reckon, but let's do it. So we're looking for two numbers that add to make negative 24, and they need to multiply to make 7 times 9, which is 63. So factors of 63. So it could be 3 times 3 times 7 is 21. So is it 21 and 3? Yeah, so 21 and 3 are the answers. So it's going to be 9k squared minus 21k minus 3k plus 7 is equal to 0. And then we factorize the two halves of this quadratic. We get 9k is the common factor for the first two terms there. So 9k, we get k minus 3 minus, we can take out this 3 here. That gives us, sorry, we can't take out 3. We can take out it's not k minus 3. Yes, I've taken out the 9k. 21 divided by 9 is 3. This is wrong. Okay. Back to the start. So we've got this here. This was negative 21 and negative 3. Negative 21 times negative 3 is equal to 63. And we have, so we're factorizing the two halves. We're doing 9k squared. So 21 is divisible. 21 is not divisible by 9. Okay, sure. Okay, so we'll take out the 3k. That gives us k minus 7. Better. And then when we take out, 3k minus 7. 3k minus 7. Then when we take out the negative here, we're also getting 3k minus 7. So therefore, this factorizes as 3k minus 1. 3k minus 7 is equal to 0. And therefore, our answers are k equals 1/3 and k equals 7 over 3. Now, we then need to read the question a bit more carefully. Now, it says here we're finding 1k such that this is true. Issue is, if we look at this function, we can see here that 7 over 3 is actually larger than 4 over 3. So that exceeds the boundary of this function. So we have to reject 7 over 3. We're going to, as 7 over 3 is larger than 4 over 3, k equals 1/3 is the only solution. Okay, so only one answer to this particular one here. All right, moving on. So now this little transformation question. This is the only transformation question on the exam, which I thought was a bit of a surprise considering how much of an emphasis they put on it last year. But yeah, maybe we're looking forward to quite a few of those in exam 2, I guess. But yeah, so we can put in this hx. So hx is that original function times by these two things here. So it is this fx plus n dx, where f and n are just both they're constants. So we can see that that's going to be equal to m times the integral from 0 to 4 over 3 of fx dx plus the integral from 0 to 4 over 3 of n dx. We're allowed to do this with integrals. We can kind of split them up. And of course, the integral from 0 to 4 over 3 of fx, given that fx we've been told is a continuous random variable, that should be equal to 1. So that's the entire domain of this thing. So this is just going to be equal to m times 1, right? And then we just have to evaluate this last bit over here. So that is, nx, 4 over 3, so 0 to 4 over 3. And if we sub those in, we're going to get m plus this with an input of 4 over 3, so 4 over 3n plus n times 0, so that's just 0. So this is our final answer, n plus 4 over 3n. Awesome. All right, last question. Now this last question is a bit of a doozy, so let's see how we go with it. So we need to find the solutions. So find 4 solutions given that w equals -3. And we're looking at these two functions here. So we're looking at this truncus and this quadratic. So what we can do to start things out is we can just basically replace w with 3. We're going to end up with 9 over x minus 1 squared is equal to x minus 3 squared, and we need to basically solve this thing. So what we can do to get started is we could multiply both sides, don't expand the brackets, x minus 3 squared, x minus 1 squared. Now, you could expand the brackets. It's going to be really messy because we have, x minus 3 squared, that'll give us a trinomial times x minus 1 squared. That gives a massive trinomial. Let's look for a shortcut here. So x minus 3 squared times x minus 1 squared, that's just the same as x minus 3 times x minus 1 squared. And if I just subtract 9 from both sides here, we get this little difference of 2 squares set up. So we can do x minus 3, x minus 1 squared minus 3 squared. And then we can see that that would factorize as x minus 3 times x plus 1 plus 3, and x minus 3 times x minus 1, x minus 1 minus 3. Okay, so that's equal to 0, right? That's a difference of 2 squares. If we just replace the x minus 3, x minus 1 with a, this is just the same thing as, a minus 3 squared. So I'm allowed to write that as a plus b. So a plus 3, a minus 3. Okay, so that's all I've done here. Now, null factor law, we need to consider each of these two cases. So let's kind of draw a line in the sand like this. So let's consider case 1, I guess, which is that x minus 3, x plus 1 plus 3 is equal to 0. So that's the null factor law of the first half of this bracket. So if that's the case, we can expand these brackets here. So that'll give us that x squared minus 3x plus x. So we're just doing FOIL on these brackets here. Minus 3 plus 3 is equal to 0. So the minus 3 and the plus 3 cancel out, and we're just going to get x squared minus 2x is equal to 0, which factorizes as x minus 2x equals 0, which tells us that x is equal to 0 and x is equal to 2 are our two solutions there. Yeah, so that's a mistake. Sorry. Let me go back. Okay, sorry about that. So this was a minus sign here, right? Very annoying when the mistake happens right at the start. So that's x minus 1 plus 3 equals 0. So x squared minus 3x minus x, because it's x times x, so that's x squared. And then we have plus 3 equals 0. Okay. So this is a bit harder then. Okay, so this is x squared minus 4x plus 6 equals 0. All right. Yeah, okay. So we need to solve this quadratic equation here. So we can use the quadratic formula. So we can see that x is going to be equal to negative b. So that is 4 plus or minus the square root of b squared. So that's 16 minus 4ac, which is 6. So that's b squared. So that's squared. Now is that right? What was this again? So this is, oh yeah, no, because it's, oh, okay, no, okay, it's all good. Okay, when we substituted this in, w is equal to negative 3, right? So this is plus. Oof. All right, they're all pluses. Okay, let's see if we can salvage that. That's plus 3. I knew something didn't look right. Okay, so then that there is 2. Okay, because if I see 3x minus x, that gives me 2x. So if we go back to quadratic formula, this is going to be negative b, so that's negative 2 plus or minus the square root of b squared, which is 2 squared, so that's 4 minus 2, b squared minus 4ac, so it's 4 times 1 times 6 over b over 2a, sorry, so that's 2 down the bottom there, right? So we have negative 2 plus or minus the square root of. Now we have 4, I'm screwing up my negatives here again, aren't I? Am I screwing up my negatives? B squared minus 4ac. Okay, I think I'm just gonna have to restart this question. Sorry, guys. Let me just redo this. I'm really sorry. I would edit this out if I knew how to, but okay. Let's just skip all this. Just skip ahead in the video. All right. Look, horrible. Okay. Let's go back to this. We have x plus 2x minus 3 plus 3 equals 0. X squared plus that. Okay. Factorizes as x plus 2x equals 0, which is x equals 0, x equals negative 2. That's our first two solutions. Okay, going back over here, we have x plus 3, x minus 1 minus 3 equals 0. Factorizes as x squared plus 2x minus 3 equals 0. X squared plus 2x minus 6 equals 0. Apply the quadratic formula. Therefore, x is equal to negative b. So negative 2 plus or minus the square root of 2 squared, 4 minus 2 minus 4ac, negative 6. No square roots of negative numbers, please. Okay, so that's going to give us negative 2 plus or minus the square root of. Now we have 4 minus 24. That gives us, 4 minus 24, which gives us square root of 28 over 2. Okay, now, can we do anything with that? Well, 28 is equal to 4 times 7. So that there is negative 2 plus or minus. Now, square root of 4, that's 2. So it's 2 root 7 over 2. That's equal to negative 1 plus or minus root 7. And putting it all together, there are answers. But I'll neaten them up a little bit for you. So therefore, x is equal to 0, negative 2, negative 1 plus root 7, and negative 1 minus root 7. Okay. Whew. Okay, now consider the case where w is greater than 0. So we're now looking at that case. So w greater than 0. All right, now in terms of w, the minimum point of the graph is this. Now what we need here is we need to work out what this is. So that's x squared minus x, so FOIL, right? So it's x squared minus wx minus x plus w, all right? So when is the derivative of that equal to 0? That'll give us the minimum. That'll give us the points of inflection anyway. We're just going to take for granted it's a minimum. So therefore, dy dx is equal to 2x minus 1 plus w. That's just taking the derivative of y here. Now, when is that equal to 0? Well, it's equal to 0 when x is equal to, again, we can rearrange this, so 1 minus w over 2. Then what we would need to do is take that 1 minus w equal to and substitute it into y. So therefore, we get y is equal to 1 minus w over 2. Now, if we're minusing 1 from that, that's the same as going 2 over 2 from that. Multiplied by 1 minus w over 2 minus w, which is the same as 2w over 2. Minusing w, yeah, that's good. So if we have a look at that, what are we going to get when we do all of that? Was that right? Yep, so 2x minus 1 plus w. No, that's right. Yep, so minus w there. W on 2. Oh, this was a square number. Okay, was it 1 minus w? 1 plus w, yeah, okay. Negative error, because this is x times negative wx, okay? Negative w there, that's a plus. Go figure. All right, there you go. So that's a plus, okay. Which gives us 1 over that minus that. So that is, so a half minus, so 1 minus 2 is negative 1, so that's w minus 1 over 2 times that divided by 2 minus 2w, so that is 1 minus w over 2, which we can see could be written as, well, I'll save a bit of room down there, so that's going to be, for example, negative 1 minus, so times what w minus 1 squared over 2 times 2, which is 4. So therefore, the coordinates are just those two things. So 1 plus w over 2, negative w minus 1 squared over 4. All right, there we go. All right, last question. Okay, hence or otherwise, find the positive values of w for which fx equals gx has exactly 3 solutions. So let us return to this function. Fx equals gx. We have here the two functions, so let's just write them down. I'll just copy them from here. So the functions are fx equals gx. So fx is that one, so that's w squared over x minus 1 squared. That's equal to x minus w squared. Okay, so therefore, if we expand that, we can get, if we multiply both sides, we get x minus w squared times x minus 1 squared equals that. And once again, we could do this whole difference of two squares trick and write it as x minus w times x minus 1 all squared minus w squared. All right, so let us consider this little setup here. When does this thing have exactly 3 solutions? Are we missing anything there? That was good. I think we're good. I think we're good this time. So that can be written as x minus w, x minus 1 squared, x minus that plus w times x minus w, x minus 1 minus w. It's equal to 0. So let's consider each of these. So if we think about this, If we were to make one of these things equal to 0, so if we were to consider the case where x minus w times x minus 1 plus w was equal to 0, what can we do with this? We can expand those brackets. So that's x squared minus wx minus x plus w equals 0, which gives us x squared minus w, let's say w plus 1x plus 2w equals 0. Or we can consider the case when x minus w, x minus 1 minus w equals 0, which gives us the x squared minus wx, or let's just write it like that. So w plus 1x minus w, plus w minus w equals 0. So the w's cancel out there. So we'll end up with x times x minus w plus 1, which tells us something. It tells us that x must be a factor, so that x equals 0 and x equals w plus 1 are going to be factors. So now let's consider about the other side of the equation here. So x equals 0 is always a factor. The positive values for w, for which it has 3 solutions. Okay, so we have one solution. Well, we've got 2 solutions so far. So let's look for the other solutions over here. So let's go ahead and use the quadratic formula on this one. Again, there's a lot of quadratic formulas in this, which is surprising. So that's negative b. So that's w plus 1 plus or minus the square root of b squared, so w plus 1 squared minus 4ac, so 4 times 1 times 2w, which is going to be 8w over 2a. Okay, so what is important about this little expression here? What's important is that when that thing underneath the square root sign, when that's equal to 0, we're going to have plus or minus 0, which means these two things are going to give us the same result, which means that in total we're going to have 3 values of x, right? So what we're interested in here is when does w plus 1 squared minus 8w equal 0? So we need to deal with that. That's going to be w squared plus 2w plus 1 minus 8w equals 0, which is w squared minus 6w plus 1 equals 0. So we need to do a quadratic formula within a quadratic formula for this one. That's going to give us that w is equal to negative b, so that's 6 plus or minus the square root of 6 squared, so 36 minus 4 times 1 over 2. Okay, so that gives us 6 plus or minus the square root of, now that's 36 minus 4, so that's 32. Factors of 32, so does 32 divide by 4? I think so, because 32 divided by 2 is 16. Divide that, it's 8, so 4 times 8. So we can write this as this, the square root of 4 times 8 over 2. And therefore we can write this as, so 6 divided by 2 is 3. So 3 plus or minus, now we had 2 divided by 2, so square root of 4 divided by 2 is that. And then we have 8 is equal to 2 times root 2, so 2 times 4, so that's this. So 3 plus or minus 2 root 2. And if we consider each of these cases, because we need to know, says here the positive values of w, if we think about it, root 2 is going to be less than root 4, and it's going to be larger than root 1. So that thing there is going to be a number that is less than 2. It's about 1.4 something, right? So we know that it's about 1.4 something. So this is going to be 3 plus or minus 2 times something that's a bit less than 1.4. So both of those solutions are going to be positive solutions. So both of them are solutions to this question. And that's the answer. 3 plus or minus 2 root 2 will give us 3 solutions. They will be x plus 1 over 2, 0, and w plus 1 over 2, 0, and w plus 1. That'll be our 3 solutions. All right, now, sorry about all the mistakes there. I hope this video was somewhat useful for you. Hope you all did really well in that exam. Couple of closing thoughts here. I'm seeing a lot of quadratic equations. Obviously, that's not going to be so much of an issue for exam 2 when you have the calculator. I am seeing just a bit of a lack of anything to do with transformations. So really look out for those on exam 2. Just because it was such an emphasis last year. So I'd imagine that they're probably going to go after them for this one. But yeah, obviously this exam, it's very dependent on your ability to do algebra. Fractions, very important here. As I mentioned at the start of the video, if you spotted any errors here, just let me know. I'll post a comment in the top down there just saying any edits that we need to make for this. But other than that, I thought overall, despite my problems, that I think this was a fairly decent exam. I don't think it was ridiculously hard. I think that last couple of questions, particularly BII, is quite hard. But I didn't think anything else in here was like insanely difficult. Feel free to disagree with me if you like. But yeah, hopefully we have the same thing for exam 2. Fingers crossed. Probably not, but we'll see how we go. All right, thanks for watching. I'll see you next time.